One of the biggest barriers in Europe to reach decarbonization targets are low rates of renovation, especially deep renovation. StepUP project contributed in making these deep renovations more attractive and reliable. So the StepUP project achieved this by working on several different aspects of deep renovation, starting with the iterative methodology for deep renovation, different plug-and-play solutions such as the active system, the envelope solution, as well as a host of digital tools and innovative financing methods that ultimately contribute to improving the deep renovation process.
The StepUP renovation methodology is separated to 5 different steps, which covers the whole renovation process. The first step focuses on the feasibility phase. During the preparation phase, we are collecting all the relevant information about the building and its users. The third phase is the design. During the construction phase, the selected technologies are implemented, and the main focus is on the speed of the installation. And finally, our methodology also covers the operation phase, where we are continuing the data collection of the building from the building users, so that we can optimize the operations of the building.
The plug-and-play modules developed in the StepUP project is an off-site solution. In our plug-and-play module, we have a light steel frame element, thermal insulating sandwich panel, and an external layer which can be realized with a wide range of possible materials. Moreover, we have also developed and patented a special anchoring system which allow quick and easy installation of the module itself, but also the adjustment of the module in all the possible directions. So it means that we can help to reduce time on site as well as wasted materials. Thanks to the presence of the insulating material inside of the modules, we can also improve the insulation of the building, therefore reducing the CO2 emission related to heating and cooling systems.
StepUP plug-and-play active system offers a solution by combining different technologies that support deep energy renovation, energy saving, and CO2 emission reduction. The first part is the heat tank intelligent thermal battery. That is a storage solution which offers very high density storage with the usage of phase change materials. And by combining this technology with the IES building level optimization that measures data from everywhere or from the building, and by combining also it with third-party products, we can achieve optimal operation of the HVAC systems.
All these developments and technologies were applied in the real and virtual pilots. So we have a Hungarian pilot, which is a kindergarten, and we installed plug-and-play envelope system as well as the plug-and-play active system in the building, along with the renewable energy such as PV panels and heat pumps. In a Spanish pilot, which are their test cells, we installed plug-and-play facades again, but these were 2 stories and were correlated. The results are being correlated to a real building, which is multiple stories, and it's also located in the same area in Spain. We have another pilot in Spain where we are installing just the active system, and finally a virtual pilot in UK where we are simply testing the digital tools. So all these pilots bring together all the developments and the technologies in the project into a more realistic scenario, proving how to use the StepUP approach in the real buildings. The StepUP consortium believes that these results have a huge potential in the renovation market, and we hope that homeowners and stakeholders can adopt these into their buildings.